All right, so let's recap everything that we've learned. So the end goal of this lesson on antiderivative rules, indefinite and definite integrals, is that we wanted to be able to evaluate integrals for both indefinite and definite forms. So these are the examples of what you might be asked to do. So first, when we were evaluating indefinite integrals, we needed to understand what this constant of integration was. And so if you recall, if we had like an integral of 2x dx, we ended up getting x squared plus c, right? That constant of integration. And so we learned that the constant of integration has to do with the infinite amounts of original functions that this antiderivative function could be, because whether c is 3, 0, or negative 2, all of the derivatives of this x squared plus c will still end up giving me 2x. And so that's why we needed a constant of integration when doing indefinite integrals. And then to be able to do indefinite integrals and eventually definite integrals, we needed to learn antiderivative rules, all these rules that we covered in this lesson. So the antiderivative rules are really important to be successful for both indefinite and definite integrals. And then we found that we were able to find particular antiderivatives, like actually figure out, hey, I want the antiderivative of this specific one if we have a given condition. For example, if we were given, like for example, 0, 3 is a coordinate pair, then what we can do is, since this is the antiderivative function, we could plug 3 as the y value and 0 squared, and then find that c is equal to 3, and find out that the antiderivative of a particular antiderivative function is x squared plus 3 using that initial or given condition. And then finally, to evaluate definite integrals, we learned that we needed to know the fundamental theorem of calculus part 2, where if you have a function and a definite integral, we just find the antiderivative function, plug in b and a, and this is new notation, and then you would get your answer. So for example, if we had the definite integral of 1 to 4 of 2x plus 3 dx, we find the antiderivative function, x squared plus 3x, and then there should actually be a plus c here. And then 4 to 1 for the notation. If you plug in 4 and then plug in 1, and then again, we need to have c's here, plus c, plus c. And then when you evaluate the answer, or if you do the rest of the math, you would get your final answer to the definite integral. Okay, so just to recap a little bit between the differences between indefinite and definite integral, indefinite integrals give functions, specifically the antiderivative function. When you do a definite integral, you get a change in y of the antiderivative function f of x. Okay, so one gives a function, the other gives a numerical value. Okay, so just know that the difference between the two conceptually. All right, so if you know how to do all 4 of those success criteria, A, B, C, D, you should be able to evaluate both indefinite and definite integrals using antiderivative rules for any kind of function.